This is the Mumbai-Pune Expressway. Built to connect two of India's most economically significant cities, it was designed to cut travel time, move freight efficiently, and reduce pressure on the older highway that had served the corridor for decades. For most of its length, it does exactly that. Except for one section. A 21-kilometer stretch through the Khandala Lonavala ghats, where traffic slows, delays become unpredictable, and accidents are more frequent than anywhere else on the route.
In a shocking incident, several vehicles, including a truck, collided on the Mumbai-Pune Expressway in Khopoli in Maharashtra.
So the question is, why does a modern expressway break down in just one segment? And what does it take to fix a problem that was built into the road from the very start? The issue isn't the entire highway. It's this specific stretch. The road here cuts through mountainous terrain, sharper curves, steeper gradients, reduced visibility. Conditions that exist year-round but become significantly more dangerous during monsoon season, when rain, mist, and waterlogged surfaces compress the margin for error to almost nothing. As traffic volumes grew, these physical constraints didn't just persist, they compounded. Travel time became inconsistent. A journey that took 40 minutes on a clear morning could take well over 2 hours in the afternoon. And when accidents happened, they didn't just affect this stretch in isolation. They brought the entire corridor to a halt. In February 2026, a gas tanker accident on this section caused a jam that lasted around 12 hours. It took nearly 32 hours for traffic to fully normalize.
Let me leave you with our image tonight, because traffic on the busy Mumbai-Pune Expressway remained paralyzed for more than 24 hours after a gas tanker overturned on the busy corridor. The accident occurred around 5 p.m. on Tuesday in the Khandala Ghat section in Raigad district, where a tanker carrying highly inflammable gas allegedly lost control on a slope overturned. Soon after the crash, gas began leaking from the tanker, prompting authorities to shut the Mumbai-bound carriageway as a safety measure. As you can see, that's the huge traffic jam right across the Mumbai-Pune highway.
One incident, one section of road, and the ripple effects were felt across hundreds of kilometers. That's not a traffic problem. That's a structural vulnerability. What makes this more interesting is that the problem wasn't unforeseen. When the expressway was originally designed, engineers had already identified the ghats as a challenge and proposed a solution. A more direct alignment that would bypass the difficult terrain using tunnels and bridges. It would have been a cleaner, faster, more reliable route from the beginning. But that plan was set aside. The tunneling technology was expensive. The engineering complexity was considered too high, and the financing wasn't structured to support it. So the road was built around the terrain instead of through it. That decision left a gap. A section that was imagined, drawn up, and quietly abandoned. Over the years, that gap came to have a name: the missing link. As traffic grew, the cost of that original decision became harder to ignore. This wasn't just about slower movement. The Mumbai-Pune corridor carries industrial freight, raw materials, and time-sensitive logistics that modern supply chains depend on. When this stretch performed unpredictably, the consequences extended far beyond inconvenience. Widening the existing road had physical limits imposed by the terrain. Better signage and incident response could reduce disruptions, but couldn't change the fundamental geometry of the route. Incremental fixes were no longer sufficient. The only solution was to build what had been left out 3 decades earlier. The missing link is a 13.3-kilometer bypass designed to replace this bottleneck entirely. Rather than following the surface of the terrain, the new alignment goes through it. The project includes 2 tunnels, one approximately 1.75 kilometers long and a second stretching to around 8.9 kilometers, making it the longest road tunnel in Maharashtra. 2 viaducts carry the road across valleys and a cable-stayed bridge rises approximately 100 meters above the ground, with a central span of roughly 305 meters. The longer tunnel runs deep beneath the surface, passing under parts of Lonavala itself. And the entire bypass is designed as an 8-lane corridor, wider than the 6-lane expressway it connects to, built to handle not just today's traffic, but the growth expected over coming decades. This isn't a marginal improvement. It's a fundamentally different alignment, one that removes the constraints of the original design rather than working around them. Even with a clear solution, building it wasn't straightforward. Construction began in 2019, but heavy monsoons reduced working days each year, and high wind speeds complicated operations on the bridge. Then the pandemic disrupted nearly everything. Labor availability collapsed, supply chains broke down, and specialized components that had to be sourced internationally were delayed by months. At multiple points, work slowed or stopped entirely. The gap between identifying the solution and actually delivering it is often where infrastructure projects are most honestly understood. Execution in difficult terrain, under difficult conditions, with a global disruption in the middle, is harder than any plan anticipates. With the bypass in place, the impact is relatively clear. Travel time between Mumbai and Pune is expected to fall by around 30 to 45 minutes. But the most significant change may be consistency, replacing a section where travel time varied wildly with one that is far more predictable. The most accident-prone section of the route is bypassed entirely. Inside the tunnels, cross passages are placed every 300 meters. Ventilation systems manage air quality, and fire response infrastructure is built into the design. This shifts safety from managing risk on an open, variable road to minimizing it within a controlled environment. At a broader level, this project reflects a change in how infrastructure is approached. Earlier, roads adapted to geography. Difficult terrain imposed limits that were accepted as the boundary of what was possible. That is changing. Projects like the missing link treat terrain as an engineering problem rather than a planning constraint, going through obstacles instead of around them. So what changed? The problem was never just traffic. It was a limitation embedded in the route itself, deferred for decades because the moment wasn't right, and finally addressed because the cost of not building it had grown too large to justify. The missing link doesn't just improve travel time. It completes a part of the expressway that was always meant to exist. If you want to understand how decisions like this shape infrastructure and everyday life, subscribe to Periscope. Because sometimes fixing one small gap changes how an entire system functions.